Okay, and welcome to Math 108, where we're going to be going through Excel charts and formulas. So really we're going to be focusing in Excel, so let's go ahead. Here in Excel, you can see that I've just made up a bunch of data here from year 2001 to 2010 with cans and miles. Cans of dog food that were purchased in my household and the number of miles that were driven that year. That's totally fake, but you get the idea. Two totally unrelated things, but we're going to look at some charts and some data. Now, often when you highlight certain things like this and you say, hey, I want to see what this looks like, the year versus the cans, you can go and insert a chart, and you can do these kind of charts are a 2D line, and you'll see one of them goes up and down like that right here. When you are comparing quantitative data, I mean, there are certain qualitative data that you'll be able to do on bar charts, but if you're doing quantitative data versus quantitative data, then you're going to want to go into these scatter plot things. This right here is what's called a time series. A time series is when the horizontal axis down here is actually time. So you'll notice this number of years in the cans, you can see I increased my purchase of cans, then it went down, then it went up, then it went down. And you could do that with the miles as well. In fact, let's do that and see what it looks like. I'll highlight all of these and insert that time series chart. Oops, wrong one. I inserted a two-dimensional. Here's the time series right here. And you'll notice the blue one's so doggone small down there with the cans, but you'll see the miles went up and went down and then decreased and stayed down for a while. However, this kind of a scatter plot right now is based solely on time, and many students will think that if time is available that you automatically have to go into time. However, when you are trying to see the correlation between two variables that aren't years, that aren't times, like this, doing the time series is not the right one to do. So when I go down here, if I do a time series like that, you can see that, whoa, what's going on there? Just do a normal scatter plot. And this is the one that you're able to do when you have quantities versus quantities, and you can start to see some sort of a pattern going on. You'll notice it arranged these things that used to go up and down as time passed from least to greatest, as it did with the miles from least to greatest. So you could see if an increase in the number of dog food cans bought and the number of miles driven has some sort of relationship. And that's really what they're doing in this early part of Excel, is making sure they know that you need to do a scatter plot if you're doing quantity versus quantity, and a scatter plot is not the same as a time series versus a time series. For the next little section, we've got to do some amortization tables. The amortization table is, hey, you've got a credit card, $3,000. It's got an APR of 16%, and the payment you're going to make, you can afford $200 to pay off this credit card, and how long is it going to take you to? And this is individual arithmetic. So at the beginning balance, we have $3,000. Oh, good. Yeah, let's put a dollar sign in front of that guy. Now notice right here it says how much payment, how much of this $200 is going to interest. This one is where you are actually taking 0.16 divided by 12 because we are at a month. This is the APR, so you must divide by 12 in order to get the right amount of interest times that 3,000. Now I'm going to hit times. Now notice you can reference the cell right there. Oh, indeed. So when you hit it, that's $40 that goes to interest. So of this, oh, look at that. We're going to equal $200 is how much you're paying, and so you're minusing this $40 right here. Enter. $160 went to principal. So of this $200, let's go and draw this guy out right here, and you'll see. So you're starting out with $3,000, and it's going up $40, and you're making a $200 payment. So it pays off that $40, and then this guy decreases $160, whatever is left. And so the end balance at the end of that first month better be $28.40. So that's what happens during that month, is it grew, you paid it off, and you paid some extra to actually take down. If you only paid $40, you'd still owe $33,000 at the end of every month. So let's go back to the Excel. And so the ending balance is going to be, it equals to this guy minus that guy, because this was just part of that $200 that got tossed out. 2840 indeed. In a formula, this beginning balance for the next month has to equal the ending balance for the previous one. Yes, indeed. So the payment, if I take this and I copy it, you can either grab this little handle, that little box there, and drag it down and it will copy it. Notice that there's less interest this month because it's 16% divided by 12, so the monthly interest rate times a smaller number. So the interest that you owe is less. However, you're still making $200 payments. So if we take this guy and take that $200 minus, it will copy down the formula. Notice how it changed to a C6. When you copy cell references, they're actually called relative references, it will move along with it. And so this guy, copy him down, and ta-da, it works. Look at that. And so you can actually take this entire row and watch what happens now. As we go down, you'll see this new balance came over here because these cell references have copied to bring that guy down. And then you owe less in interest, so of your $200, more is being paid to principal, and you can keep going. Now, the reason this is called an amortization table is it is amortized. How long will it take this $200 to pay off a $3,000 credit card? You notice we're down from $3,000 down to $1,300 now. Let's keep going, highlight all those and drag. Ooh, right there. So you'll notice right here, yeah, at this one you owed, so in month 17, that actually went to 0 and forever else. Good. Now, Excel does a few things, and it's kind of important to know how this works, because this amortization works, and you're like, okay, well, what if I only paid $100? Let's put 100 up here and see what happens then. You're like, well, nothing changed. Right, we have to go in here and change the 200 to 100. Okay, so if we do that, it changed a lot of stuff. So we got to take this and make sure and copy this guy all the way down. Oh, shoot. If we're only paying off $100, we got a longer way to go. And let's see, how far is that? Oh, yep, we got it far enough. So it took us 38 months, 3 years. Oh, nope. Yeah, over 3 years to pay off before we started going negative. That's kind of cool. So the question is, what payment would let us land at, say, exactly 2 years right here? Excel has an awesome way of doing this. And watch this one. It is called the payment formula. So if we equal the payment, PMT, of, and notice it has this, the rate, 0.16 divided by 12. Why do we divide by 12? Because we took the annual interest rate, and it requires the rate for each period, each month in Math 108. So the number of periods, we want to pay it off at exactly 2 years. That's 24 months. The principal value is this guy right over here. That was the $3,000. And then final value, you can actually just leave that one blank, or you can put a 0 there. Either way, because it has that bracket around it, it is not necessary. So let's find out what payment it would be. $147. Now I want you to note that this came out negative. Why did it come out negative? This is essential for you to know when you're helping students, because many of them that need help will not know this. When we put it into the formula, this was a positive number, which means this money, even though we owe it, I understand, this money is like a loan. It is going into our pocket when we take out that loan, and this payment is going out of our pocket, which means it's a negative cash flow for us. Not for the loan, not for the debit card, not for anything. It is a negative cash flow for our pocket. So if we want this to be a positive number, we have to put a minus sign in front of that payment formula so that it's a, hey, it's a $147 payment. And I bet is there a little bit of change on there? Oh, look at that, $146.89. Excellent. So now you'll notice we'll have to go back and change this guy to $146.89. So now we're going to teach you something that's really valuable. This 100 right here, I'm going to make it that guy. Oh, look at that. Now we have to make sure and copy that everywhere. right? We're going to take this, and if we copy it, look at what happens. Oh, shoot! Something just messed up. What happened? This is the opposite of that. When we copied it, it moved this D2 to D3. Did we really want to take this one minus that one? No, we wanted to peg this guy solid. So up here, we want this D2 to always remain absolute, no matter when we copy it. And so the way you do that is by dollar signs. If you put a $D and a $2, then that will make it so that when you copy it, it will always keep D2 in the formula. That's called an absolute reference. So when I copy it, look at what happens. See, now let's look at it. It's still D2. And if I copy it again, it's still D2. See, look at that. The other way to do it, just so you're aware, is, let's highlight it and delete it. I can show you what, if you click on D2 and then you hit F4, it automatically puts the dollar signs on there and makes an absolute reference. So then when I copy it all the way down, it doesn't, that particular cell doesn't move, and it should have gotten to 0 right about. Oh, look at that. The payment function is genius. It figures out the exact amount to get you down to 0. And that will be very handy. Now I want you to notice this. What if we had $4,000? Wow, that made a different payment, but notice it didn't get us down to 0 at 24 months. What happened? Well, this didn't change. Notice here, we should have equaled this and made it an absolute reference so that anytime we copied it, it would refer to that. So these guys, notice that this right here needs a relative reference. So when it copies, it's always referring to the guy next door. This one needs both an absolute and a relative reference, and that guy just needs a straight absolute reference. So this first row is actually pretty intense between pegging things that are up here that will be used for the entire whole table and those things that are going to be referred to next to it there. Let's look at one of their projects so you can see what it looks like. And yeah, 24 months, bingo, right on the dot. Here they have a beginning mortgage, and you'll see that they have, let's zoom in a little bit so you can see that. There we go. They are going to, this is one of their projects, they're going to buy a car, or buy a house, excuse me, and they're going to put a picture of it and see what style and square feet and bedrooms and bathrooms, and they're going to have listing prices. Notice again that it gives them a hint on each one of these. These need to be followed correctly so that when they go to the How Do I Do page, they can see all of these turning green, and it will walk them through each one of those. But each one of these, like on a 30-year mortgage, right here, monthly payment. You're going to use the payment formula. The total payments will be how much you paid here times how long the loan is. And that will happen on both of them. And when you get to the end, this one will have to go, let me see, 30-year mortgage. So this one you'll have to copy when you finally get row 2 done. So row 1, some of them are going to have, absolute reference. The payment, which is going to be up here, is going to be an absolute on the interest rate times this relative reference. To the principal will be the payment absolute minus that guy, and then the ending balance will be right over here. Kind of fun that you'll have this ending balance, beginning balance, and then you'll keep going, and all of these, by the time you get done with row 2, you should be able to highlight all of this and copy it down, and it will keep going, and you'll have to copy it down to 360 rows. Over here, you'll have 180 rows. And so remember, step 1, step 2, they have to use a little bit of research. Step 3, they actually fill out the 15-year, and then they fill out the 30-year. Then step 5, this right here, you're going to write the monthly payments, write more interest paid, and they're going to process a lot of stuff here. It's kind of neat. Then they're going to sell their home for an amount of money. So you have to actually go down and look at row 120 to see how much money they made when they sold their house. And it's pretty doggone cool when you see that. That'll help you with that particular project. They will have an option to do that loan project or to compare a savings and loan. Now this one has a little twist to it that you'll need to know. They're going to buy a car and they have to research their loan details, or they can put in this sort of thing when they do step number 2. Now step number 3, on this side you'll actually compute the loan just like you did on the mortgage. And it's pretty good. The loan will probably be 3 or 4 or 5 years, so it only goes 36 or 60 rows. Over here, however, on the savings side, what they're doing, you have to pay attention to the instructions. They're saying, what if you saved up the same amount of money each month, but were able to buy the car with cash later on? So sales tax and purchase amount, follow these instructions as you go down through and say, okay, but we could get a savings APR and save for the same amount of months. That would be pretty cool. What is our monthly payment to get to there? Yeah, what's our monthly payment? And it will actually be smaller than this monthly payment. And you will pay less money than you paid in here. And when you build this amortization schedule, it's going to be different than a loan. Here, you're going to start with the beginning balance, which is previously saved. That is an absolute reference. Then the interest earned is going to be the APR divided by 12 times that guy, plus this payment goes into it, and you will end with this balance. Then it will start over here. So it will be adding these two together onto the beginning balance, and it will add and add and add and add all the way down there. And then you can fill in how much you ended up paying and how much your car actually cost, and you'll look at, hey, I earned money over that time. And it's a really cool project for them to be able to do. Aside from the ability to do all of the amortization tables in Excel, Excel has those built-in formulas. And we talked about the payment formula. Putting a negative in front of it, but what payment it would take to, with this interest rate and the number of periods and the final value, the principal value that's coming to you, and to pay off the loan, what payment would do. And it actually automatically computes it for you. There are some other ones that are pretty cool, and here they are. This guy right here is if you start with a principal value or an original amount, and you just let it grow. So this is called a lump sum, and you just let it grow. That's all it does. And you can see this is percent change. So the interest rate for the year divided by the number of months, this is normally a 12. Number 12 times the number of years, and it just grows. That's great. This guy is actually an infinite series, or not an infinite series, but a finite series, summing it up, and that's where this big formula comes from. But if your students will not recognize that, so that's all right, don't mention it. It says if you add a certain amount of payment in, then it grows, and then you add another payment, and then another payment. It keeps going over and over and over and grows up to a final value. So this is on a payment program. And you'll notice that this formula is both of them put together. The equals FV formula in Excel does both of these. It is this one right here. And if you start with zero principal value, you're left with this one. If you don't add anything, you're left with that one. But if you have both, they just add together. So the final value formula is really pretty cool. So final value, and it'll say, what are you starting with? Now, if this is a savings account, so it'll have the interest rate. So you'll put the interest rate, but always divide by that. Then it'll have the number of periods, which is NY. Good. Now it'll say, what's your principal value? You put in the negative of how much you're starting with, because this one you are investing. And so that thing is going away from you. So that's why it's negative. Also, the payment that you are adding in every month has to be a negative number because it is going away from you. That is crucial to know when you're helping students. And then it'll ask what type of thing, meaning does the interest get added in at the beginning or end of the month, but usually just ignore that one for them. And so when you put this in, the negatives are going to be beneficial. Now on your packet, you actually need to plug this in with a calculator, but Excel can certainly do it for you very quickly to help you check your answers. Okay.